So we're in the Lake Gillard water treatment plant. Water flows by gravity from Gillard through a hydroturbine into the plant. Because there's a large difference in elevation between the turbine and the surface of the reservoir, there's a lot of pressure differential, so we can generate power losing some of that pressure across the turbine. So there's a small Francis turbine on site. It produces about 10% of the power for the treatment campus, which includes the treatment plant and the pump station. It's obviously a renewable energy source, and at today's rates, it produces somewhere around $150,000 worth of power a year. From there, it goes through a rapid mix and into our flocculation basins. So flocculation, it's basically a process where our coagulant, which has a positive charge, and the raw water particles, which typically have a negative charge, combine to produce larger particles. The typical raw water particle itself, you can't filter out, but if you combine it with a coagulant and make a bigger particle, it's easily filterable and removable. So we can use chemicals to make the filtration process more efficient. The next step is it goes right on to our filters. So we have 16 filters here. I believe each filter is capable of producing about 5 million gallons of water per day. The filters contain granular activated carbon, which help remove organics and taste and odor compounds. So the flock particles end up on the filters, and every so often we need to backwash that material off the filters, otherwise they essentially clog. You can't pass water through them anymore. So that material is backwashed off the top of the filters and goes through a process which actually removes most of the solids from the water. We have inclined plate settlers, which basically is essentially a large surface area which uses gravity to make the particles settle on plates and slide to the bottom. So we're removing those solids, and they're pumped to our drying beds, which they're dried to about 25% solids. Processing the alum residuals on site is a benefit to the community for a couple of reasons. One is lower cost water rates. We're also producing a product that is used for beneficial reuse. So instead of essentially throwing it away, it's blended with sand and organics and uses soil amendment. After we filter the water, we don't have a finished product yet. We add sodium hypochlorite to provide a free chlorine residual in the distribution system, so you have a disinfectant to make sure that pathogens don't grow after it leaves this treatment plant. We also add fluoride, and we add a corrosion inhibitor. So the pipes in people's homes don't corrode.
Every day when I come in, we're doing a bunch of different lab samples. We're testing the quality of the water. We're seeing how the water responds to the chemicals that we're adding to it, our filtration processes, and making sure that that water is at the highest quality that we could produce. So we do basic tests, pH, alkalinity, we'll check chlorine residuals, make sure we have enough disinfectant in the water, and all these chemicals interact with each other, so it's making sure you have the right balance at all times so the filtration process works properly. So one of the most important things that we test for is turbidity. It's the amount of particulates in the water, and the more you have in there, the cloudier it looks, a higher turbidity value it would have. So you would want the lowest turbidity possible for the cleanest water, and it's the most appealing water. We have a number of sample sinks, so what I could do is I could take a sample of water from a different process, and I could see how it responds to an individual chemical, see how it's reacting, and follow its progress through the treatment plant.
Every single day, the laboratory as a whole receives samples that are having to be tested for many parameters, many different tests. Specifically in this room, we measure for bacteriological analysis, where we're looking for strictly bacteria that could be harmful within the water itself. We use several different techniques. Some of them are 24 hours that take to process for an answer or a result. Others take 5 to 7 days. But to our customers, the water bill that we pay, this is all part of that. As a matter of fact, I'm a customer. My water bill that I pay based on my usage, I expect the laboratory is doing a good job. I'm thankful because I work in a laboratory, so I know the water's good. You know, I just happen to have that added benefit. But concerning the laboratory, all of the analyses, we're bound to have to meet water quality guidelines. We just can't put out water without testing it and knowing what is going out. So we're certified. And every single year we have to go through certification. Every single one of the individuals within this laboratory is tested, and they're blind tested. They're given samples that are called performance evaluations twice a year. And they're like, here, do this, give me back the result. If you fail, guess what? You're not allowed to do that test. You have to pass. So we need to make sure that what we're doing is done properly and done correctly. There's really no ifs, ands, or buts on that.
Well, I think the biggest myth is that, you know, the water comes from the sky, it's free. What are you guys doing to, you know, charge me all this money for my bill? What happens is we have a lot of equipment, personnel that make sure that that water is treated, filtered correctly, and meets state, federal guidelines, and is great tasting and easy to get right out of your tap.